All right, let's get started with our very first bit for the year. Methods in algebra. Nothing too mind-blowing here, but here we go. Ready? Hey, like terms can be added or subtracted. Unlike terms cannot. Truly amazing. I don't think I even bothered with examples for that one. I guess all we're highlighting is, look, a pronumeral is an unknown. You don't know what it is. That's what it represents. So therefore, I can't add them with another unknown unless it's the same type of unknown. I still don't know what the value is, but if I've got an unknown here and the same type of unknown, I know I've got two of them. So I can go, well, x plus x is 2x. That's the basic idea, of course, behind algebra. Our index laws, just a quick revision of those. We remember that when we multiply, we add the powers, and when we divide, we subtract the powers, and when it's parentheses, we multiply the powers. And then, of course, there's this little one here, which is often misquoted as anything to the power of 0 is 1. And I say misquoted because that's not true. Right? Who actually thought it was anything to the power of 0 is equal to 1? You know, be honest. Raise your hand, anyone? See, no one's put their hand up there because they're going, you just told us it wasn't true. So, okay. Because all you need to do to disprove something is find an example where it doesn't work. Give me an example where it doesn't work. Yeah, that's it. 0 to the power of 0. 0 to the power of 0 is not equal to 1. If you don't believe me, try it on your calculator. Other than that, everything else will be 1. But 0 to the power of 0 is not equal to 1. Okay, but what does an index mean? You've been working with indices for a whole heap of time now. But you actually know, what do they mean? And when we introduce it with a real simple idea and say, it's the number of times you multiply a number by itself. So if I've got 2 cubed, I know I'll multiply it by itself 3 times. 2 times 2 times 2. And that's a fantastic way of defining it when we're talking about positive whole numbers. That meaning loses itself when you start dealing with other things. So if it's positive, the way I think of it, positive means I'm on the top of the fraction. Negative means I'm on the bottom of the fraction. I suppose technically it's probably more correct to say positive means I'm on this side of the fraction, and negative means I should be on the other side of the fraction. Because if you have a negative power in the bottom of a fraction, then really that should go to the top of the fraction. All right, fractional powers then. A over B. Well, the top tells you the power. The bottom tells you the root. Now, easy way of remembering that, of course, is if you had x squared, we all know what that means. But squared, or 2, is really 2 over 1. So it's 2 tells you the power, bottom tells you the root. We don't really think of the first root of a number, because it's just itself, of course, same as anything to the power of 1 is itself. But I mean, that's what it really means. So we have the bth root of x to the a, or of course, you could write it as the bth root of x all to the power of a. Both are correct, of course. I guess it depends what you're doing with it. If I have to actually calculate a number out, then I'm probably going to go the second way. Because I'll find the bth root first, because that'll usually make a number smaller, and then raise that to a power. Rather than going to the power first, which will make the number bigger, and then I've got to find the root of a bigger number, and that's probably going to be a bit harder. But when it's algebra, I tend to go the first way. I'll go the bth root of x to the power of a. All right, quick little examples. Ooh, -3, negative. Ooh, I'm on the bottom of the fraction. So we draw in a fraction bar, which of course, proper name is vinculum. Thank you, well done. So, vinculum, x cubed goes to the bottom. The minus sign was the instruction, so we don't put that down. So x cubed, there it is. And of course in algebra, it's actually 1x to the -3. 1 is to a positive power, so it goes to the top of the fraction. A mixture, a to the 5, b to the -7. Again, we just follow the instructions. The positive power goes to the top of the fraction. Negative power goes to the bottom. A to the 5 on b to the 7. Oh, hey, let's get real tricky now. 3/4. Oh, they've done that one for us already. How nice of them. 3 goes to the top, 4 goes to the bottom. X to the power of 4 is on the bottom. A to the power of 9 is positive, it goes on the top. B to the power of -2, it goes on the bottom. Fractional power. Top tells me the power, bottom tells me the root, so that's the fourth root of x. 2/3. Oh, well, top tells me the power, bottom tells me the root. Cube root of y squared. 3/2. Now, a mere mortal would write the answer like that. The square root of x cubed. But of course, that surd can be simplified. And we always simplify our surds. Okay? Because x cubed, I could rewrite as x squared times x. And x squared is a perfect square. And that's the whole idea you'll remember behind simplifying surds. You try and find a perfect square that goes into the number. So the square root of x squared is x root x. There's an easier way of seeing that. The way I see that is, whilst I might see 3/2, I'm thinking 1.5. Now, you never write powers as mixed numerals. That's bad notation. But if you think 1.5, it's telling you the answer. X to the power of 1 times x to the power of half, x root x. So I can write the answer down straight away. So if you've got an improper fraction as the power, you can always simplify the surd straight away by making it a mixed numeral. And I'll tell you how it simplifies. So if I had, I don't know, I'm sure you do this many a time, you have numbers to the power of 27 on 4. It happens so often. So 27 on 4 is a mixed numeral. I can simplify that straight away when I turn it into a mixed numeral. What is that? 4's into 27. 6 4s are 24, aren't they? So we got 3 3/4 there. So that would be m to the power of 6 and m to the power of 3/4. Well, 3/4, top tells me the power, bottom tells me the root. So m cubed, the fourth root of. Bang, I've simplified it all in one hit. Just be careful with your notations. This one, it kind of looks like power of 64 if you're not looking at it straight. When you're doing roots, you sort of try and put the number inside the V shape, if you know what I mean. Put the number there so you can't mix it up with a coefficient of or a power of the term in front. There we go. Hey! Often in maths, what we like to do is get a simple a concept and try and make it more complicated. But of course, if you break it down one by one, there's our vinculum. Half, oh well, we know how to do that. 1's on the top, 2's on the bottom. I'm just not writing down the 1 because in algebra we don't usually write 1 down when it's the coefficient. -6, it's on the bottom. Positive 500, it's on the top. -1 on 28, well, it's on the bottom, but 1 on 28, well, that would be the 28th root of q. So on the bottom goes the 28th root of q. C to the power of 7 on 6. Oh, it's positive. It's on top. 7 on 6 would be 1 and 1/6. So it's to the power of 1, c to the power of 1, times c to the power of 1/6. Power of 1/6 would be the 6th root of c. So we have c to the power, no, almost confused myself there. C times the 6th root of c. So you can see how you're setting out, and that's very important. So you don't, unfortunately, I had no choice using PowerPoint how I could set that out. But if I was handwriting it, I'd try and get that 6 a bit more in the V there, so I can't get confused. And that just leaves us with r to the power of 69. 2/3 to the power of -2. When you have a fraction to a negative power, remember I said another way of thinking about negative is, oh, actually I should be on the other side of the fraction. So what we can do is simply turn it upside down. Because the negative is saying, oops, I should be on the other side of the fraction. So we'll put it on the other side of the fraction, but now it's a positive power. And then that's often easier to do. So 3 on 2, all squared, 9 on 4. 9 on 4. There we go. Our first exercise. So 1A, asterisk on number 18. That must be one of the extension questions. That'll be a bit of fun to look at. And 6A, which I think is on indices. It's just that 1A I thought was quite simple, so I thought, let's pull out an exercise where I'm a bit further on to have a bit more of a challenge as well.